Hi, hello everyone. Continuing from last time, where we actually created with our WebGPU this screen, which is just basically empty screen. So goal of this video is actually to render something to that screen and to have this kind of triangle on the screen. So before that, let's just discuss code from the last time. I have added some comments that will be clarification of some of the stuff that we did last time. So you can either continue from your code or you can check out my GitHub account, and I will link basically GitHub account in the description of the video. How do we actually render this? Just let's discuss our pipeline, graphics pipeline quickly. So just that we have a quick overview of what we're going to do. And this is how the pipeline works. So basically we have, sorry, I had something in draw buffer here. We have these stages. And basically the graphics pipeline just moves through these stages one by one. That's why it's called pipeline. And what do these stages do? Well, first we have a geometry data, and that's just our data, which might be array of points in JavaScript. Let's say, let's take a look at it here. It might be just something like this, right? Geometry data is it's some kind of array, and then we might draw something at position minus 0.5, 0.5, it might be 0.5, 0.5, and then maybe something like this. Basically, it's just a geometry data. It's nothing more than just a data. And why is this data important? Well, because in next stage, which is our vertex stage, and that's actually for the vertex stage we can write code, and that code is executed for each of the vertices. So what does this mean? We had this geometry data, right? Let's imagine that this is our screen, and our screen coordinates go from -1 to 1, and let's say that we specified some vertex at position 0, 0.5. Then in vertex stage, and let's say that we have some vertex here as well, and in the vertex stage we can say what do we do with this point, and we can move it maybe here, and that's how we do our transformations, rotation, scaling, right? We might scale it down, and then this point might be here, this might be here, this might be here, or we can scale it back to well, the other position, or we can just rotate, and then it might be here, might be here. Anyway, you get the idea. And that's our vertex stage. And how does it actually execute? So let's say we had this point up. Let's say that we had this point here, this point here, this point here. So how many times will vertex stage execute? It will actually execute 3 times. One for this, and this. All right. So uh, it, it it doesn't have to execute for each vertex. We say how many times it will execute, and I will show it a bit later. And then we have primitive assembly. What does primitive assembly do? So I mentioned that we had this, and this. And primitive assembly actually tells what do we draw here. So in WebGPU or with 3D APIs, at least the APIs for rendering raster graphics, you can either draw a point, line, or triangle. And then what do you want? How do you draw a quad? Let's say you want to draw a quad. Well, it's 2 triangles. How do you draw a cube? Well, it's a lot of triangles. All right. And the primitive assembly, we just say what our primitive will be. So point, line, triangle. Then we have rasterization. And what does rasterization do? Let's say that we had our triangle, and then rasterization is responsible for well, basically moving these triangles to pixels, right? In the end, on the screen we have pixels. We don't see triangle as something, we actually see pixels, and that's what rasterization do. And the fragment stage, this is important stage as well, like vertex stage, because in fragment stage we say what to do for each of these pixels here in this triangle, and usually we just color them, texture them. Well, that's basically it. We might discard them. We might say if coordinates, you might say discard these coordinates here, and then only this guy is drawn. That's one example. So fragment stage, we will do it in example, and we will see how it works. So we're going to code vertex stage today and fragment stage, and then I'm going to also mention primitive assembly a bit because we have some control over this. Rasterization, you can even forget about it because you don't have control over it. Color blending and testing. So this is a bit more advanced. Uh, in the end, if you have more geometry, you might have something behind this and then something behind this. This is terrible drawing. Let's go again. You might have triangle here, but you might have some guy that's behind it or something that's behind. It doesn't have to be triangle, of course. This is just basic example. It can be anything. It can be model in your game which is behind the other model, and in color blending and testing you kind of say what to do with it. All right, especially if it's like a mirror, or sorry, not the mirror, if it's actually a glass, because you have to deal with transparency, and you do that here usually. And the frame buffer is our final image. So just that you are aware, we actually never draw to screen directly, we actually draw to texture. So let's say we have a flower here and then sun here in our texture, and then our screen. Up, 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 up. Right, and then we just present that texture to the screen, and that's how it works. So that's basic overview of the pipeline, and with that said, we can actually start coding. Let's see. All right, let's start with code. So just for note, okay, let's remove this. Let's do this. So we're going to do this guy first and this guy first. So what are we going to do? We're going to create a shader, and the shader is just a code that executes on the GPU. And for WebGPU, extension is WGSL, standing for WebGL shading language. All right, let's actually start with that, and then I'll explain it as we go. Okay, let's move here, and actually let's just create a new folder. We're going to call it shader, and then here we can just say shader. I mentioned extension WGSL. Okay, and then let's just start coding. First, we're going to have some struct, which is going to be our vertex shader output. And here we're going to use this built-in, which is special keyword in WebGPU shader, and then we can say position. So this will be our final position of our vertex, and here we can just say position, and it's going to be type vec4. And then also let's add location 0 color, and color we're just going to pass it to fragment shader. We're not going to do anything with it. And then we can say vertex, and this is special keyword, so this means this function will be main. It will be main vertex shader function, and let's just call it vertex main. And here what are we going to take it? We're going to take another built-in. So built-in it's like a keyword. It has special meaning, and there are a bunch of built-ins. I'm going to comment them when I finish this. And then we're just going to say what is the output, and you specify it like this. So basically this is what's going out. And then let's, one thing to note, let's see here. I mentioned that we have to pass this geometry data to GPU, but we're actually not going to do it yet. We're going to do it in the next video. We're actually going to embed our data in vertex stage, so in a shader. Okay. And how do we do that? I have this position, and let's just specify our data. It's array of vector2, and this can be, yeah, this is fine. This is probably fine as well. Suggestions are probably fine. This is bottom left, bottom left. This is bottom right, and this is, well, top right. Yeah, that's fine. It will still be a triangle. It's just not the one that I drew at the beginning of the video, but it doesn't really matter. It's a triangle. And then we're just going to have define our output. It's going to be this, right? And we're just going to return this from the shader. And what do we do here? So we have this output position, and we're actually going to take vector 4 because right here the type is vector 4 and the position is always vector 4. We're going to take vector 2 and then just the other arguments. We don't care about z-axis, and this we will discuss it probably in future. I don't want to bother you with details now. And then for color, we can just specify any color. So this is fine, this is just red, and we're going to return the output. And then we actually have to do fragment shader. As you remember, pixel fragment shader, it's responsible for coloring each of the pixels, each pixel of that triangle. So this is responsible for vertices, and this is for pixels. Same kind of thing. Actually, this is not correct. We're actually going to take frag data, and it's actually vertex output. So vertex output is input in our fragment shader. And we return vector 4, which is basically a color. And then we can actually fetch color from that frag data dot color. Maybe this is a bit more readable, I think. Is it? Let's see. I think it kinda is, but let's just discuss this quickly. So I don't need this. So we have our triangle. I think it's, let's see, here goes to here, and it goes to here, I believe. So this is our triangle, and we have this, oh no, something like this, right? And we have this vertex index. So what does it say? A vertex index is something that you specify when you call draw. We're going to get to that, but it's essentially just spaces 1, 0, 2, 3, 4, etc. You can specify, or when you call draw, you specify how much of these vertex indexes do you want to call essentially, and then we're just going to call it 3 times for these uh, 3 edges, right, for these 3 vertices. And then yeah, that's fine. So vertex shader will run 3 times here, 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 and then fragment shader, well, fragment shader can run a bunch of times because it runs for each of the pixels here. Sorry, those are some ugly pixels. Okay, and then what do we need to do further? We actually need to create our shader. So let's just do this. Let's import our shader source. And we can just import it as text. So we don't have to load it. We just need to say question mark and then row at the end, and that should be fine. I think so. Shaders. This is, I call it shaders. And then shader, so I think it's fine. I'm not sure why it's complaining though. Oh, I'm missing a keyword here. Okay, that's fine. And then we're going to create our pipeline. It's GPU render pipeline. And then we can just create some function that's going to load that pipeline. We're just going to call it prepare model because in the future it will be a model, maybe. And then we actually need to do this. So now there is a bunch of steps which are just used to configure that pipeline. So we create a shader module from our shader source code. Then we have our vertex state, so state of vertex shader. So it's just going to say GPU vertex state, and it takes some arguments. So module, entry point. Entry point is here vertex main, so let's use that. And then buffers. We're going to cover buffers in the next video. So buffers is how you do pass data from the CPU to the GPU. And then let's just do this fragment state module, same, and deploying if frog is fragment main here, perfect. Then further, still in fragment state targets. Let's see here, format. So just a format, coloring format, and here we can actually do what we did before. Get preferred format. No. That get preferred canvas format. So we just need to say in which format will our pixels be. And then, oh, what's happening here? Maybe I can format it a bit to make it a bit more readable. No? Okay, let's see further. And finally, we just need to create our pipeline. Create render pipeline, vertex, we need to pass vertex state, fragment state, our primitive. What are we going to draw? So this is important. We will change it later, but as we discussed, we are actually going to draw triangles here, so we're drawing triangles, but we can also draw a line or a point. Okay, and layout auto. We don't care yet about it. I will actually explain it in the next video. We just have to specify it. And that's it. That's our pipeline. And finally, let's see. No, not yet. Of course, I have to draw it. And then we had this draw here. And we actually use our path encoder. Like I mentioned, we must encode everything. So we're going to set our pipeline, and here we're just going to say draw 3 times because we're drawing for 3 vertices. All right, let's see now. Do something change? Exit full screen maybe. I'm going to do it like this, and I cannot find my window here. Let's just see. Oh, this is completely broken. Okay, let's actually do this. Give me a second. Let's use this. I have a bug. Let's say it's not of type. Of course, we have created a method, right? Prepare model, but we never called it. And yeah, this is good place as any. So now we actually get our error from our shader. Okay, I missed something. Let's see. What did I miss? No. Maybe I can hide this. We say, oh, keywords. This language is full of keywords. We just say location 0, and now you can see that we have drawn something, which is perfect. So this location will be more. It will become clear next video where we're going to spend some time with it. But the important takeaway is it's really this thing, built-in position. So this is our final position of our vertex, and then here we're actually outputting vector 4 for our RGB and A values. So red, green, blue, alpha. And here we can actually experiment a bit. So I already mentioned, not here, but actually here. Let's just experiment a bit. I mentioned that we can draw triangles, but we can also draw line list. It doesn't work because it needs more vertices to draw a line. So let's see. We're drawing points, but they're so small that you cannot see them. And what else do we have? Line strip maybe. As you can see, if we were to add one more, let's paste here 4. because lines are working like this, right? We previously we had triangle, but for lines you kind of have to specify. All right, you have to specify once here, once here, once here, and then you have to wrap it back here to finish it. So that's the reason why it's not drawn, and that's easy to fix. We just need to pass for here, and then we can say now shader. We just have to use bottom left once more, and then it should work, as you can see. All right, so you get the idea of it, right? It's not that hard. You can play with this example, and so for the next time, what we're actually going to do is it's really all going to be about our geometry data and how to pass that data to Vertex so that we don't have like to encode our data in shader like this. So we're actually going to pass it in. Anything else that's important? No, I think that's it. So hopefully you figured this. This is important, right? How many vertices to draw. What's important is to know this. What does this do? Topology. So draw points, draw lines, draw triangles, and yeah, this whole shader loading is important, and of course the most important thing is knowing the shaders. But if you don't know it, if you're just wondering, oh, what does it do? What can it do? Don't worry. As we go along, you're probably going to get feeling for it. It's not that hard, actually, because shaders are usually really simple. The complexity comes from the math itself. Like when you do lighting, for example, lights are a bit more involved, but the shader themselves that they're usually really easy. There is not that many syntax and then stuff that you can do is really constrained. Okay, so next time, geometry data, and hopefully you enjoyed this video. If you like this video, please like it, subscribe, and see you next time.